Good morning, everyone. Today we're looking at Unit 4, Lesson 1, Primary Trig Ratios Review. So you would have covered primary trig ratios in grade 10 and grade 11, whichever math class you took. But some things to remember, that we can only use these trig ratios when we have a right triangle. So we have a right triangle ABC here, and we've labeled some of the sides. Now those sides are labeled based on the angle that we're referencing. So if we say that angle A is our given angle, and we'll call it theta. And we label our sides based on that angle. So the hypotenuse is always the side that's across from our right angle. So that always is that side, no matter what angle we're referencing. Our side across from our given angle is called our opposite side, and the side that's touching or next to our given angle is called our adjacent side. So let's just recall, what are these ratios? So we say that our sine ratio, or the sine of theta, is equal to our opposite side over our hypotenuse. Our cosine is our adjacent side over our hypotenuse. And the tangent ratio is the tangent of theta is our opposite side over our adjacent side. And we use an acronym to remember this. So hopefully we remember the acronym is SOHCAHTOA. So we take the first letter of each part of our sine ratio. That makes the first part of our acronym. So SO is for sine equals opposite over hypotenuse. And then we say ka, and that represents the first letter of all of those parts of the ratio. And finally, TOA. So first letters there. So SOHCAHTOA, sine is opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So let's look at some examples of how do we find missing sides or angles using these primary trig ratios. So my first example, we have an angle, and we're working with two sides. We know one of them, we're going to try to find the other one. So we would say that this 20 degrees, if we don't know it, we call it theta, but this is our given angle, and we do know it, it's 20. All right, and then we look at what sides are we working with. So here I have my opposite side, I'm going to call it O, and I have my adjacent side. So O over A, if I look back up at SOHCAHTOA, means I'm going to use TOA. So I'll set up my tangent ratio. So the tangent of theta, in this case theta is 20 degrees, is equal to my opposite side, which is 105, over my adjacent side, which is x. All right, so now we have to solve for x. So I'm going to put this tangent of 20 over 1. It doesn't change its value. If we divide something by 1, it still equals the same thing. So now I have two fractions. I'm going to cross multiply them. I'm going to do x times the tangent of 20 is going to equal 105 times 1, which is just 105. And then I'm going to divide both sides by the tangent of 20 to isolate x. And when you do that, you should find that x is equal to 288.5. I'm going to pause the video. I'd like you to try doing B, and C is finding an angle. Go ahead and try to do that one. See if you remember, how do I go about using my trig ratios to find a missing angle? Okay, there's your solutions for those two examples. B is no different than A in terms of identifying which ratio you need and then setting it up and solving for the unknown. C, we had to find our angle. So we saw that we had a variable for our angle. Our given angle was theta, but we were working with our opposite and our adjacent side. So that tells me we're going to use TOA, or my tangent ratio. So I set that up with my values that have been given to me. So the tangent of theta is equal to my opposite side, which is 32, over my adjacent side, which is 20. Then to isolate for theta, to solve for theta, so to move this over here, we take the inverse. right? So the tan inverse of 32 over 20 is going to equal 58 degrees. And that's how we solve for an unknown angle. Okay, the next question is asking us to solve triangle ABC. So when it asks you to solve a triangle, it wants you to find all missing sides and angles. So anything that's unknown. So here we know two angles. So the easiest thing to find first would be to find that third angle. So let's find angle B. And the sum of the angles of a triangle is 180 degrees. So if we want to find that third angle, we can just take 180 and subtract from it the angles we already know. So angle B is going to equal 55 degrees. All right, so we know that this is 55 degrees. I'm going to pause the video, go ahead and find the two sides of that triangle using your trig ratios. So if you use your trig ratios to find side length AC, you should find that it's 17.1 centimeters when you use your tangent ratio. And then if you try to find AB or your hypotenuse, you can use your cosine ratio of 55 degrees. And you should find that it's 20.9 or 20.9 centimeters. Another way to find that hypotenuse is once we know two sides, we have another equation or formula we can use to find that third side, and that's Pythagorean theorem. So we could have used a squared plus b squared equals c squared to find that hypotenuse. All right, and remember that c squared is always our hypotenuse. So I'm going to plug in the side lengths I knew. If I didn't know this 20.9, I could plug in 12 squared for A and 17.1 squared for B, and that would equal C squared. So I'd have 144 plus 292.41 equals C squared, and this would equal 436.41 equals C squared. And then in order to find C or to isolate for C, I gotta take the square root of both sides. So if I take the square root of both sides, I would again get 20.9 equals C. So it doesn't matter which way you do it. You could use a trig ratio, or you could have used Pythagorean theorem at that point to find the third side. So something else to review for primary trig ratios is that angle of depression and angle of elevation. So an angle of depression is the angle measured below the horizontal. So it's always made, these angles of depression and elevation are always made with some horizontal line. So if we're talking about an angle of depression, we kind of create that imaginary horizontal line, and then the line of sight down to the ground with that horizontal line creates our angle of depression. Our angle of elevation is usually created by the ground, which is our horizontal, and then the sight line up. That will make our angle of elevation. So always with the horizontal. Both of them have to be made with the horizontal. So we'll try the first one together, and then we'll pause and we'll get you guys try the second example on your own. So it says a sailboat is approaching a cliff. The angle of elevation from the sailboat to the top of the cliff is 35 degrees. So let's draw a cliff. So we have a cliff. And we're going to draw a sailboat somewhere out here. Alright, sailing on the water. It says the angle of elevation. So that's the angle made with my horizontal, which we'll pretend that the water is horizontal. And then the line of sight up to that top of that cliff. Alright, and that angle of elevation is 35 degrees. So it says the height of the cliff is known to be about 2,000 meters. So we have a 2,000 meter cliff. How far is the sailboat from the base of the cliff? So we're wanting to know, what is this distance here from the sailboat to the cliff? So let's let x, we should always explain what our variables represent. Let's let x represent the distance from the sailboat to the base of the cliff. All right, so if 35 is our given angle, we have a right angle made here from the cliff and the water. We're going to label what side lengths we have based on that given angle. So this is my opposite side over here. The unknown side is our adjacent side. Okay, we could label our hypotenuse, but we don't really care about that length. We Just know that we're working with our opposite side and with our adjacent side. So therefore, we're going to use tangent, which if we remember, so could TOA. Okay, is tangent is equal to opposite over adjacent. So we'll set up the tangent of theta is equal to my opposite side over my adjacent side. In this case, theta is 35 degrees. Our opposite side is 2000, and our adjacent side is x. So we'll go ahead and cross multiply those again. I'm going to do this in one step this time. So if I cross multiply my x over to my tangent 35, then I'm going to have to divide my tangent of 35 over to the other side. So it's going to look something like this. We're going to have 2000 divided by the tangent of 35. We'll just finish this work over here. If you do 2000 divided by the tangent of 35, you should find that x is equal to 2856.3. So we'll always come back to answering that question. So therefore, the sailboat is 2856.3 meters from the base of the cliff. Okay, I'm going to go ahead and pause the video. Try to do that next example by your own, or on your own, and then hit play again to see the answer. Okay, and there's the solution for the next example. Just something to remember about this example is that this example discusses the angle of depression. So the angle of depression is always made with that horizontal. So from Captain Jack to the base of, or to the end of the ship, there's an angle of depression, which you can see is the angle that's made on the outside of the triangle. But the angle of depression that's 60 degrees, if you follow it all the way down, it makes a Z pattern with the angle of elevation. And those two equal each other because they're alternate interior angles. So that Z pattern that's made means those two angles are equal to each other. So once we know the angle of depression, we know the angle of elevation as well, so we can use that in our triangle. All right, and then from there, it's just another primary trig ratio problem. We ended up using tangent and found that the side length that was missing was 34.6. So we always come back to answering that question, which asked, how high is Captain Jack from the deck of the ship? So Captain Jack is 34.6 meters above the deck. Okay, that's it for our note for today.